So hello everyone, and welcome to this new panel at this second annual Zero Emission Bus Technology and Transit Operation Conference. So my name is Maria Denis. I'm a Membership Success Officer at CUTRIC, and it's my pleasure to welcome you to this super panel about realities and solutions ahead in Canadian charging solutions for full fleet electrification. So I am joining from Mississauga in Ontario, and in the spirit of respect, reciprocity, and truth, I would like to honor and acknowledge the lands which constitute the present-day city of Mississauga as being part of the treaty and traditional territory of the Mississaugas of the Credits First Nation, the Haudenosaunee Confederation, the Huron-Wendat, and Wyandot Nations. Recognize these peoples and their ancestors as peoples who inhabited these lands since time immemorial. I would also like to thank the sponsor of this panel, which is Nova Bus. Our conference would not have been possible without our sponsors, so we thank them a lot for their generous support. So today we have the pleasure of receiving not one, not two, but 6 panelists. So first of all, we will have my two colleagues of mine from CUTRIC. So Roberto Sardenberg, who is a senior lead in data science and knowledge management at CUTRIC. And he will be joined by Parvati Pillai, project manager at the ZEB Consulting Services and Business Development. So they will talk to us about the Route I 3.0 and Cloud Transit 2.0 tool, which were launched earlier today, among other things. Our second presentation will be done by Teresa Cook, who is the Vice President of Corporate Business Development at Siemens, and she also happens to be one of our board members at CUTRIC. Then we will have Mohamed Muriwed, Product Manager at ABB E-Mobility, followed by Vince Roto, Director of Brampton Transit. And last but not least, we'll have Erin Cook, Project Manager of the Bus Electrification Program at Winnipeg Transit. So without further ado, I will leave this virtual stage to my colleague Roberto and at Parvati for our first presentation. So Roberto, the floor is yours.
Thank you so much, Marie-Eve, for presenting me here. Those are kind words. Parvati, do you want to speak a few words?
Sure. Thank you, Roberto. Thank you, Maria. And thank you for the opportunity for the ZEB Consulting Services team to showcase our prowess in the empirical analysis wing in this presentation as well. We are going to be having the senior lead in our team on data science and knowledge management, Dr. Roberto Sardenberg, present before you the realities and solutions ahead in Canadian charging solutions for full fleet electrification, looking at some empirical data. Over to you, Roberto.
Thank you, Parvati and Marie-Eve. Those are very kind introductions here. Again, thank you everyone for joining us here for this panel. I'm glad that we have some time to discuss charging solutions because that will certainly be a very good portion of the transit electrification efforts here in Canada. And as Parvati and Maria have introduced, I'm a senior data scientist here with CUTRIC, so I'm the forefront of both predictive modeling and empirical data analysis as well. And today will be more focused on the empirical data analysis for this presentation here. As just behind Parvati just presented the Cloud Transit tool in a few presentations prior to this one. We have built this data analysis tool that is capable of gathering real-time data from different data loggers from different assets spread across different transit agencies. We assess data from vehicles, charging or fueling infrastructure, electricity meters, chargers, and so on. So we access KPIs. We report them to the agency so that they can take informed decisions. We monitor key parameters, for example, state of charge in real time, so that we ensure like the buses are not failing their service. We use that data to validate our prediction modeling as well. As Elizabeth pointed out earlier, we are refining as time goes by. Like each day we are trying to improve the accuracy of our predictions based on empirical data analysis as well. We calculate GHG emissions reductions. We evaluate the performance under different environmental conditions. So I will be focused on one project that we have utilized our Cloud Transit 2.0 tool that is focused on BEBs, even though we have capability of analyzing fuel cell electric buses. We, in fact, have done so. And not only that, anything related to transit, CNG buses with renewable hydrogen, ridership operational data. We have a very adaptable and sophisticated tool for that. But specifically for BEBs, we have this project, the Pan-Canadian Battery Electric Bus Demonstration and Integration Trial, for which we have three champions here, three transit agencies that have deployed 18 battery electric buses and 7 high-powered overhead chargers, to which we are focusing our attention here, the performances of these specific issues here from multiple manufacturers. So we have different vehicle manufacturers and different charger manufacturers as well. And TransLink, York Region, and Brampton Transit are the three agencies that are providing us with all of that data that we think will be like very valuable to help even like other transit agencies, because we have been talking about like learning from people that go first. So this project is very important in that sense as well. So I'll present a few key parameters here, a few performance indicators. And it will be a very short summary because we have the capability of going in very much detail, ranging from, for example, tracking the accelerator pedal or the brake pedal to essentially have a measure of driver behavior. And we can go also analyzing each regenerative braking episode on those buses and make sure that each one of those episodes are accounted in the overall statistics. But I'll focus on a few KPIs here. So across all of those vehicles, we have tracked already more than 300,000 kilometers. And we have estimated that more than 650 tons of CO2 equivalent were saved. And the average energy efficiency of those buses is 1.26 kilowatt hour per kilometer. And you can see something interesting here, which is not necessarily just the average efficiency, but the distribution across the years. And you can see an interesting pattern here, a periodic pattern, which is the efficiency ranging from like something just above 1 kilowatt hour per kilometer to 1.5 kilowatt hour per kilometer. So close to 1 in the summertime and closer to 1.5 in the winter time, when the vehicles also need to heat their cabins. So that is a very interesting pattern to note here, and it helps to relieve some of the anxiety here, because the energy efficiency is not like blowing up to very high values during the winter. Now, I'll also show you here very briefly the power level, because as I mentioned previously, we are tracking 7 opportunity chargers. We have looked at more than 17,000 charging episodes, and the overall average power for the session that we have tracked so far is 2015 kilowatts. That's one very interesting thing to note as well. Even though chargers might be rated at a higher power level, so 450 is one standard that we have, the bus will not necessarily always be able to accept all of that charging power during the whole session. So there's an average, and for these for this trial, we are observing something a little bit more than 200 kilowatts across all vehicles, across all of the period of analysis here. And I would also present this last slide here, which is the average charging time. So we have been observing that the vehicles require approximately 30 seconds to dock an opportunity charging, approximately 1 minute to undock that charger, and about 5 minutes of actual charging time. And the distribution with time resembles that periodic pattern that you see as well with variations with the seasonality here. But essentially, those agencies are being able to service their vehicles on almost continuous basis with approximately 5 minutes of charging. And yes, those will be my key highlights here for this project. And I hope I'm looking forward to receive your questions and increase the discussion. Thank you.
Thank you, Roberto, for that great presentation. Now would be the time. If Parvati, do you want to add anything at this point, or do you want to come for the Q&A after when we have questions?
Sorry, I had a little bit of trouble unmuting myself there. We will wait until the Q&A because I believe our audience would be having a lot of questions for me and Roberto. We'll be happy to take them then. Thank you.
Excellent. Okay, then perfect. So then we're going to move on to our next presenter, which is Teresa Cook, so Vice President of Corporate Business Development at Siemens. So Teresa, the floor is yours.
Thank you so much, Marie-Ève. Hello, everybody. You know, with spring coming, I've been thinking a lot about planting, and we have a little herb garden in our kitchen, just one of those indoor planters, and it gives us our fresh basil. And I was thinking this morning how it's sort of like our trials and our projects so far have been a bit like indoor planters. And they've been good because we've learned how to keep plants alive and get the basics going. And now our challenge is to build a huge community garden. And in fact, tons of community gardens all over our country. And they're not just going to be for a little basil on top of pasta, but they're going to be to actually critically feed thousands of people. And so that's really the challenge in front of us. It's exciting, it's daunting, and we have to transform our skills, our understanding, our social structures to be able to actually deliver this challenge. So today I wanted to offer a couple of seeds for our springtime planting in the hopes of contributing. So the first of my, okay, yes, I want to proceed. My 3 seeds are about interoperability, the value of software, and then designing the right charging architecture. So interoperability, CUTRIC did a brilliant thing in creating this trial. And what it did was really made very obvious the challenges of interoperability, where we have vehicles and charging systems that are live dynamic software systems that have to work together. And I think what's become obvious is that we have to change our mindset. We cannot stand here and be reactive when it comes to interoperability. We actually have an opportunity to become proactive, and it's an economic opportunity. So my call to action here is let's create a network of test centers. And this could be led by Transport Canada or another federal ministry. And in each of these centers, we put chargers, we put software to manage the energy, we put the different DER assets that we need, and we offer testing, consulting, and training services so that we can actually embed these capabilities into our local communities. That's seed number 1. Seed number 2 is about software. I think we are all learning that we're in a digital transformation. And so there's two places that I think software, when used skillfully, is going to really help us in the journey. The first is in the planning phase. So this slide is about the planning phase. And within the planning phase, we can use software in a couple of ways that are very helpful. Number one, we use it to study the routes and see, okay, what can be electrified? And if I can't electrify it this way, maybe I can reblock it and electrify it another way. And great, that gives me the state of charge when the bus enters and the state of charge it needs to be when it leaves again. And it may give me also my peak load. Wonderful. Now, okay, I know that peak load, but what is the load curve going to look like at 15-minute intervals? We need that curve over time. So this is where we have to look at what are the charging parameters, and again, simulate, not guess, but simulate using software tools. What is the optimal configuration of these chargers going to look like? How can I smooth out that load? And what exactly will that curve look like at 15-minute intervals? And then once I know my load curve very well, or scenarios of load curves, then I can look at supply. How do I actually supply that energy? And what are all the different possibilities? And again, not guess, but actually plan and check with software, what is the optimal solution set looking like? Shifting to the operational phase, software again can really make sure that we optimize the OpEx and the reliability of our community garden. So here just it shows in a very simplified way the different architectures that we have. We're going to have software to manage the charging. That's what we see on the left. We're going to have on the right all of the different energy assets, and we have to have software to optimize those in real time based on the pricing and whatever's happening on the grid. And then we have to have integration into the depot management software, all of the telematics. We need to know where the buses are at the right time so they don't get stranded. And we have to actually do systems integration work between all of these different systems. And so Siemens can help advise on some of these charging architectures or overall software architectures, if that's helpful as well. Moving up from one community garden to multiple, many transit operators have multiple sites. And so in a way, we'll become like a mini electrical system operator. And that's, so exciting and so daunting. And you can see here in this slide, it's trying to show that you've got multiple sites. You need to be able to manage the charging and understand the energy and trade and transact across these multiple sites with your electricity system provider. This is just an example I wanted to show of a depot we have in Nuremberg, where at the bottom of the slide, it's showing virtual power plant. So the depot is actually connected to the utilities virtual power plant and is able to transact to lower its demand charges. So that's what I mean when I say optimize and lower your OpEx. You're transacting with the grid through the software. Okay, so that was my second seed, was the skillful use of software. And my third seed is about the charging architecture. There's no one size fits all. We have to look at your site, just like, if I just randomly put a bunch of tomato plants too close together, which I have done, they all grow together and it makes a big mess of tomato plants, right? Now, it's the same here. We have got to look at your site. We have to look at what are the right options here. The traditional is just, distributed chargers, and that's great for scaling. They are easily, moved around. You can get one at a time. Another option that we're looking at with customers is we put them in an e-house, which is a kind of a separate building that's very good for rugged conditions, and you can service your equipment just by walking inside the building. And then some of our colleagues have centralized multi-charger systems. And these are also interesting in terms of looking at the amount of cabling and installation and trenching and so on. So, but we have to really, my key message here is we have to think about it. It needs to be assessed and looked at in terms of the overall trade-offs for your specific site. So my 3 seeds in summary for successful planting this spring and going forward is, let's get proactive on interoperability. Let's take advantage of the economic opportunity. Let's skillfully use software. And I know that's a transformation for all of us and for so many people in this field. And let's design the right charging infrastructure and architecture for your site. I'm really looking forward to continuing this transformation together, and I wish us all a very fruitful garden.
Thank you very much, Teresa, for that great presentation. I really like the analogy with the garden. It makes me want to go in my backyard. Thank you, though. So we're going to go to our next presentation now. So Mohammad Muriwed, Product Manager at Abbe E-Mobility. So whenever you're ready.
Good afternoon, everyone. Merci, Marie-Ève. Thanks for listening in. I basically wanted to give you a quick overview of what Abbe is doing in this field. Myself, I'm a product manager with Abbe E-Mobility, and basically I've joined the e-mobility about 2 years ago. Before that, I've been involved in the smart grid, energy efficiency, power generation with renewables, solar and wind, as well as battery energy storage. And this is what I wanted to bring into the presentation today, of the different challenges and solutions we're looking at when we're thinking beyond the charger and working together into moving from those little small projects and small gardens into more like a community garden, as Teresa mentioned. So basically, what I'll be emphasizing as well is the ecosystem that we need to look into. We'll bring in a case study as well, and then present it, bring a focus on the key takeaways and the new solutions that we're bringing into the market. So this is something that we've presented that you've seen in other presentations, how we're looking all together to bring into this sustainable future. So I'm not going to spend too much time on it. Abbe basically in Canada has been really committed onto bringing this e-mobility for greener and cleaner transportation, and with the clean energy that we have in the country. This will help bring the transportation sector, which is one of the main polluters in the industry traditionally, into a much cleaner, contributing to the overall economy, as well as the cleanness of the environment. So what about Abbe? We've been in Canada for more than 100 years, contributing on the all electrification of the grid, as well as the automation, bringing in renewable energies, as well as smart grids. And we have a very diverse team, so more than 3,000 employees, with pretty diverse from different nationalities. We have 30% female workers, as well as we're based out of Montreal, mainly from the building that you see in the photo. And we do have the Center of Excellence for e-mobility in this building for all of North America. So bringing back to the community gardening analogy, so we really need to look into the ecosystem nowadays. So previously, let's say in the last 10 years, all the evolution has been that we have a charger here, a charger there. And what's really important is to really look at the overall picture and how we work all together, from between the bus operators, the OEMs, the chargers, and not forgetting the utility and the infrastructure that needs to power all those chargers and infrastructure. So with Abbe, we've been developing all different solutions that help in the overall picture. So going beyond the charger, looking at the service and life cycle, basically trying to make the most out of those chargers during the lifetime, different applications of energy storage, integrated solutions, container-based solutions, whether it's AC to DC power or DC to DC with a common DC bus, as well as energy management solution. And most importantly, going forward, we're looking at software and the importance of how to optimize and put all this together. From the product that I wanted to present to you, it's basically for the past presentation from last year, we've presented our solution where we have a power cabinet optimized for the bus industry with 150 kilowatt power. So basically, the solution that we had was fitting for the limited powers needs that are needed for the market. But going forward, we're looking at the introduction of the second half of this year of the 360 kilowatt solution, which fits in exactly the same size as the 150 kilowatt power cabinet. So it's pretty much the same infrastructure, and this enables, in addition to the sequential charging that we were providing, parallel charging to provide 4 outlets at the same time, and basically optimize the cost and the infrastructure need going forward. So this way we could provide 4 outlets of 90 kilowatts, or if one bus is available to charge, it's only we could provide the 360 kilowatt with a pantograph application. So this could be mixed, whether it's a pantograph or a cable-based application. And so far, we've been providing this for North America, so for 480 volt AC input in the US and for 600 volts as well in Canada. One of the success cases that we have is in Lake Tran on the Great Lakes, and basically with this was for charging new Flyer buses, and we're looking at 6 charges of 450 kilowatt each. So over here we're getting into, think of it as an overall, we're almost getting to the 3 megawatt multi-outlet charging, and this is really important to keep in mind because this type of power is not available everywhere. And when we're thinking about the charging and becoming mainstream electrification for all the buses, we need to think about this type of a megawatt charging level and how to manage this. And as Teresa mentioned, software becomes extremely important. So first of all, we are introducing solutions that we want to make sure that we're only using the power that's available to us. And later on, introducing battery energy storage and peak shaving, so making sure that we're with software optimizing the energy use, as well as integration of solar, wind, and other resources of energy, including weather forecasting, fleet scheduling, based on all those different parameters. And this is where really it becomes extremely important to bring this all together to give us the overall view and to make this ecosystem work. And this is what I see the step 4 going forward. Like we really need to work together as a community to bring this all together as a solution to the industry. Thank you very much, and leave that for questions and answers or at the end of the sessions if time permits.
Thank you very much, Mohammed. That was very interesting as well. We do have some questions. I will invite the public, the audience, if you do have any questions, feel free to write them in the question and answer chat, and we'll look at them during the Q&A session at the end. So now moving on to our next panelist. So I'll invite Vince Roberto, Director of Brampton Transit, to present us your projects.
Thank you very much, Maria Eve. So I'm Vince Roberto, Director of Transit Operations and Maintenance at Brampton Transit, and it's a real pleasure to be here at the conference to talk about our pilot and what we've learned from it and where we go next. So we're part of the pilot that was talked about before. Let's continue down this. Sorry about that. Trying to find what, there you go. Thank you very much. I hope you can see that. So we started a pilot with 2 Nova buses and 6 new Flyers and 4 chargers. We started in May of 2021, interestingly enough, just after the pandemic hit, but it was an interesting and busy time for us in many ways, including the electrification. So we picked 2 routes. And we electrified 1 short route fully with the Nova buses, and we put as many as 6 buses on another one of our routes. And for us, the interoperability part of this pilot was as important as it was for us to learn about electric buses and electric vehicles, it was equally as important for us to look at the interoperability, because for all of us transits, none of us want to be in a situation where we buy a bus and then are married to a charger for the rest of the time we have that bus, or buy a charger and then be married to that bus for the rest of it. So we want any bus to work on any charger, and that's really what this pilot was all about. Can't seem to find a way to trying to move down the next slides from here. I can't seem to flip the slides for some. Thank you very much. So this is one of our stations. This is our Mount Pleasant station, and we've got two 450 volt chargers here, and we've got a 1 megawatt transformer that was built. And this was a really interesting part for us. This is a connection to a GO train, which is the interregional train system, and commuter system in the GTHA. So it's an important location for us. These are where the two Nova buses come out, and you'll see they come up here. They're opportunity chargers. They go up there, and they charge. There's two stations because we wanted to make sure we could charge a couple of buses at a time, because both routes connect here, not just the one. One interesting thing for us was to look at where the charger was. We decided to not let people board or alight our buses while they're being charged, not for any safety reasons, but one interesting lesson learned was if the bus is charging, there's not sufficient room for somebody in a wheelchair to get on the bus. We would not have enough room to engage the ramp and have somebody board or alight. So we charge, and then we pull up to the stop to get to. Next slide, please. Okay, on Queen Street, this is the end of one of our lines. So this is an on-street charger. So the other one is in a terminal, in a station. This one is actually on the street. This is a very busy street in Brampton. This is Steeles Avenue, and it's probably, if not the busiest street with truck traffic in Canada. It's got to be very, very close to it. And so we had all kinds of issues about how long the line into the location is, what protection is there around. You'll see the bollards around the transformers there. We looked at certain reflective treatment we could put on the charger to make sure in the winter and in rain and whatever, it's visible. Now it's pretty much above any truck, but you always have to be concerned about these charges in traffic here and what might happen. So far, it's been working out pretty fine for us. One issue we found was depending upon exactly how close the bus was to the curb, you might have trouble engaging and charging the bus. So we had to do some training there and some treatment paving practices. Next slide, please. Those previous ones were ABBs. This is Siemens charger at our Sandalwood garage. So it's the one we've got in depot, but it's not indoors. It's an outdoor one. And we use this to charge the buses at our Sandalwood garage. And one of the interesting things we found, you see some of the pictures in the top right and the bottom right of that, it was a much more complicated thing to put it in our location than we thought, because under that roadway there, which is the way our buses get into our maintenance bays and circle our facility, there was all kinds of utilities under there. So even finding locations to run the cables and stuff was a complicated thing, and locations, but we found them. Next slide, please. So for us, talking about the successes, I think we've been at it for pretty much a year now. These buses have been very reliable. The chargers have been very reliable on balance. It was slow getting off the mark. There was all kinds of issues where we had breakdowns, and we couldn't figure out or didn't know right away whether it was the charger, whether it was the bus, whether it was the software on the charger, the software on the bus, the interface of the two. And so there were lots of issues early on. Those things kind of got better as time went along. So we're comfortable, and we think this is a success. We think it was really important for a pilot program. And Teresa talked a bit about this pilot program, but I think the whole program steering committee that was set up was all designed to have us all learn at the same time, learn from each other, and to be a collaborative thing. So we had a program steering committee with both bus manufacturers and both charger manufacturers and all the transits involved in it, with help from CUTRIC staff as well. I think that collaboration was critically important because we were all kind of going down the same path together. One thing we're particularly proud of is that once we got started with phase one, that trial was completed both on time and on budget. From a delivery perspective, and that in the middle of a pandemic, it was remarkable all unto itself. Something else we've been able to confirm is that, yeah, there are in fact efficiencies versus the actual the consumption of energy on a diesel bus particular. And so that, and Josipa talked about this before, but certainly you need the cost savings. You have to have those cost savings to help offset the upfront cost of the higher cost of a battery electric bus versus a diesel bus, and there are savings there. Next slide, please. So for us, as I said, some of the overall challenges we had were we're big on doing root cause analysis of breakdowns here. So if something happens, we don't want to just fix it. We want to be able to, we need to fix it and then find out exactly what did happen so we can determine the root cause and come up with a permanent fix. So I would say certainly early on, a root cause analysis was a problem, and it's a critical thing. So if you're looking at getting into any technology, but in particular these battery electric buses with the chargers, insist on some kind of a root cause analysis. The configuration between the BEBs and the chargers is also was challenging. I think it still to some degree is challenging, but it hasn't, as I say, things seem to be more a little more reliable today. And then there hardware malfunctions. This is brand new equipment. Some of it's out there, and you're going to have those kind of things. So in each of these circumstances, for us, we want to know right away how do we fix it, because right now we've got two routes. If we go off one route from a bus perspective, then we can just substitute diesel buses on it. It's only 2 buses on one and up to 6 on another. Because of the pandemic and reduced service we have out there, we're able to accommodate that. But when we get to, fleet-wide distribution, we're not going to be in a position where we've got extra buses hanging around just in case a line goes down. And that's what you learn is if it's the charger, then it's pretty much the line that goes down if you're relying on that on-street charging. It's not just a problem with a single bus. And we'd sure like our OEM partners to be in a situation where if we have issues out there that we're able to get real quick responses. And so we're paying a lot of attention to that. And as I say at the bottom, there 2 routes are doable. System-wide, these kind of challenges are things that we're going to have to work through as quickly as we can because they're problematic or can be problematic from an operating perspective. Next slide. So for us, where are we going now? Well, we want to complete all of our predictive modeling to make sure we are comfortable with all of the savings that we're getting, and we're looking at doing our. Now we got the 2 routes. We got to do a Z implementation strategy and rollout plan. So how do you roll it out, route by route, and where? We are looking at for the infrastructure, is there going to be third-party energy services involvement? I know that our friends at TTC have signed an arrangement with OPG to look at that. I think it's fair to say from Transit's perspectives that this charging infrastructure is in many ways beyond what we normally would do, or a level of expertise, and we're looking for ways to look at third parties to come in and help us with that. As I mentioned before, service level agreements for uptime are critically important. We always want warranties, and on-time performance is really critical for us. And in our business, we all know as transit operators, you can't live without those things. And you can't always wait till the morning. You certainly can't wait a long time for parts to come in. So those are all things that are really, really important. We're in the process of designing our 3rd facility. That's a major new bus garage and maintenance facility we'll be building. And right now we've got the funding for that to be diesel or diesel hybrid, but it needs to be, we need it to be electrified as part of this. So we've got funding under see the last bullet there, the Zero Emission Transit Fund. We're making an application to that fund for financing for that. That's just on that new facility. We've got 2 other facilities, our Clark and our Sandalwood facilities, that we're going to have to go back and retrofit, and we're looking at ways to fast track that retrofitting as quickly as we can, because we don't want to wait for the 3rd facility to open before we continue with our electrification. So there's all kinds of things we're going to be doing to try and do that. We're happy here in the city of Brampton because we've been able to work with the Canada Infrastructure Bank. We signed an MOU, and we're very close to finalizing the financing agreement where we will take the predicted future savings from operating battery electric buses compared to operating a diesel bus, and use those future savings as a repayment mechanism for a loan we'll get from CIB to cover the higher upfront cost of these buses. So we'll look to traditional funding mechanisms like the ISIP program and ZETF to help pay for the base part of the bus. And we'll look at the CIB loans to cover the higher incremental cost to be paid off over the life of those buses. And so we're all in here in Brampton. We're ready for it. We're working hard, and we see this as the future. And we're really excited and proud of the pilot we've had and how well it's worked. And we're looking for a very bright and electrifying future, if I can use a pun. So thank you very much.
Thank you very much, Vince. So we're going to move on to our last but not least presenter. So it is Erin Cook, Project Manager of the Bus Electrification Program at Winnipeg Transit. So Erin, when you're ready.
Great, thank you. I'll try to go quick because I know people want to get into questions. I'm Erin Cook, the Project Manager for Bus Electrification Program at Winnipeg Transit. Excuse the coughing dog in the background. Winnipeg Transit has a long history of electrification. We completed a 4-year bus demonstration of en route charging in 2018, and a lot of the data from that trial has built the basis for our electrification study beyond. So lots of people ask, why are you continuing to study? Why are these buses not on the road? So when we started this, the technology wasn't at the level it is today, and we still had a lot of questions in terms of how to implement it. So we undertook a study to relook at where the technology had gone in the last couple of years, and did a very detailed economic analysis of the capital cost and the infrastructure cost or operating cost. But it was still a very high level in terms of scope of what it would look like for our fleet. So since that time, we've been working on the detailed zero emission rollout plan, which we hope to release hopefully in another couple months here. And what this is going to describe is all the major infrastructure projects that are going to have to take place across our multiple facilities in order to actually implement this technology. And what we're looking at is the cost of fleet electrification across is exceeding $1 billion. So we can't afford to get it wrong. So the need for study is very important to maximize the public dollar on these projects. Also, we can't go super fast into it because of this, because we're basing it on where the technology is today, and everything is evolving super fast in this industry. So we want to be able to scale up in a rate that is consistent, with the economic realities and the technology today, and flexible enough that we can change as we go along. But this is a change across the entire organization. We're looking at new workforce development, a lot of operational uncertainty, and we're not built for these major infrastructure projects at transit. We want to deliver on-time service. So all these things are things that we're learning as we go. So we're one of the few transit agencies that has sort of come out of the gate saying that a mixed fleet solution is where we want to go. Rapid charging, we've tested previously. The technology has kind of moved away from that to a large extent, but en route charging may still make sense for us in strategic locations throughout the city. Long-range buses are likely to make up the largest majority of our fleet, but there is still a portion of about 30% of our existing service with 60-foot buses and 40-foot buses that are really long and challenging for battery electric technology to meet today. So today I'm talking about the battery electric, and tomorrow I will be talking about the fuel cell bus program as well. Charging is incredibly complicated. This is just looking at some of the decisions we've gone through on our bus side. from what type of charging infrastructure, en route versus depot. But even once you get into those decisions, there's a lot of complexity, plug-in charging, overhead charging, and all the sub-projects that created off of that. Do you have power to be able to support the charging that you've selected, either from a location that's outside of your facility, or do you have enough localized power to support depot charging? In addition to that, if you don't have enough utility power, on-site generation, battery storage, all these things are going to be needed for resiliency, as well as potentially secondary sources of power during outages. So we've discovered that power demand is a huge problem. Energy is not power. So a lot of people, when they look at their study, they're only looking at energy consumption of the buses and how much energy you're going to use. And those things are manageable, but power is something that really is what impacts your operations. So that's how many chargers are operating simultaneously, how many do you need to operate simultaneously in order to maintain your service. And all of these will have capital and operating trade-offs. You can buy more chargers, but your risk is that your cost of electricity is too high. And you need to look at things at higher backup resiliency to support that strategy. Whereas if you look at higher bus to charger ratio, then you have to reorganize entirely how you think about fueling your buses today. But the benefit is, you can probably run this off a basic generator or something that's already in your service today. So this is sort of optically what I just talked about. When you first sort of start looking at what your service looks like today, swapping out battery buses for diesel buses, you're going to end up with some kind of morning spike and some kind of evening spike. If you had a 1-to-1 charger ratio, this is one of our bus garage that's about 130 buses. We're looking at 10 megawatts of power. We in reality only had about 5 to work with, maximum maybe. But we wanted to see what we could do with bus to charger ratio, and we kind of tamed these peaks, but they're still fairly high. So we undertook an energy twin study with Siemens actually to help look at, okay, what can we do with software to make this better? And they were able to shave off another 500 megawatts or so, our kilowatts, sorry, off of our peak loading, and give us a better picture of what our energy is going to look like. And also giving us options for if on-demand charges start to implement, how we can time shift this in the future. So my recommendation to people starting this journey or already in the process is really to work closely with your utility to determine what your limitations are when it comes to power. These may be different at each one of your facilities. It certainly was with all of ours. And you're going to have to look at various different options to get around this. So if grid power doesn't work, can you solve it with load shedding and smart charging? If that doesn't work, can you implement more capital with energy storage to help that even further? Or do you need to start looking at service increases with your utility, and what are the costs and timing associated with that? And beyond that, solar generation may be part of your broader city plan in terms of your net zero. So is that something that could help minimize some of the utility costs and timing? And then if all else fails, you have the 2 sort of nuclear options, which are hydrogen as a way to electrify those facilities that just don't have enough power, or building a new garage at a new location. So thank you today for your time. I hope I didn't speed through too quickly, and look forward to answering your questions.
Thank you very much to everybody for great presentations, very inspiring. So we're gonna move on now to Erin, if you could just mute yourself. I think there's an echo. Thank you. So we're gonna move on to the Q&As now session with everybody. And so I see in the chat that we do have a lot of very interesting questions from the audience. So I'm going to start, first of all, with a question from Ashley Hooker. This one I think would be specifically for maybe Teresa and Mohammed. So Siemens and ABB, are the opportunity chargers prone to fail or need redundant systems? Do they work with all battery chemistries, or do they always degrade the battery? Sorry, but feel free to jump in as well. The other panelists, of course, as well. So maybe Teresa first.
Yeah, so they're working reliably, and thanks to CUTRIC, we have that data there showing the reliable operations. And of course, the key is to have service technicians and scaling up that service capability to have those responses and that root cause analysis being performed as quickly as possible between, and just noting that interdependency between the bus OEM troubleshooting and the transit agency and the charger OEM. So this is why I say we cannot just like break this apart and magically hope that it's going to just solve itself. There's an interdependency. We have to work through this. We have to stay aware of it and understand how do we address these problems as quickly as possible and systematically, so it doesn't just keep happening to us like out of the blue, you know, on a live transit system.
Thank you. Mohammed, do you want to go?
Yeah, at least in North America, we're lucky in a sense that we've adapted the inverted pantograph, so the pantograph down basically. And this gives a possibility that you can have, like, let's say, backup options versus, let's say, in Europe or the rest of the world where they have the pantograph on the bus. Then if something happens to the pantograph, then you're really out of operations. So at least with this side, the bus keeps operational. And then from the opportunity charging point of view, you're typically charging at the beginning and like at 2 points along the route, for example. So this really brings some redundancy in the design.
Thank you very much. Okay, interesting. We do have another question. This one is extremely precise. It's for Roberto from Jonathan Cusay. So he asked about the average energy efficiency, value of 1.26 kilowatt hour per kilometer. It's a very large sample with various meteorological conditions, but are there any constants in this data? For instance, weekday, weekend service, medium, heavy duty, use of electric heating or air conditioning, similar average elevation of the routes to help us put this value in perspective. So Roberto, do you have anything to respond to that?
Yes, sure, Marie-Eve. I will actually go one step back and also jump into the Ashley's question a bit as well, if you don't mind. So overall in the project, we are not seeing that those chargers are prone to fail. We have been observing like good reliability. Of course, like you should expect some issues, like in general, like deployment of new technologies does not come with some adjustments to be made, but that's the role of CUTRIC in this project, to integrate and to help like the communication between the agencies and the manufacturers, help that troubleshooting. And we know for a fact that those chargers work with different battery chemistries. And I'm not sure if I got the thing about like degrading batteries, because like that ultimately is it has to do with the bus, right? If the bus will have like a good battery management system, it will not allow the battery to be degraded, because it will only accept that power level that the battery can actually handle. So that's more like a bus related question than a charger related question. But yeah, I just wanted to put that point out. Now, regarding Jonathan's question about the overall statistics of the data that we got, I would say that unfortunately, I'm not at the liberty to provide me like a huge breakdown here in terms of weekday, weekend, medium, heavy duty, as you pointed out, and electric heating, cabin heating. What I can say is that there's no constant in the data, as you mentioned. Like we are aggregating all of the data, both like weekends, weekdays, like in periods in which the service is more close to like the medium duty cycle, and some periods with the heavy duty cycle, with a bus with more passengers and then more electric heating. There's a small portion of the fleet that heats with diesel heaters, but most of the buses are heating their cabins with electric heating. And with elevation, I would say the routes are pretty similar. So with all of that variability, you can see that the data is still like shows like a very predictable and steady energy consumption, again, between that range of 1 kilowatt hour per kilometer in the summer and close to almost 1.5 in the high of the winter. I hope that helps a bit.
Thank you, Roberto. Yeah, no, that's very interesting. I do have a question for Vince regarding the Brompton buses. So Bentley asks a question related to the charging rate. How long can you charge the bus with 450 kilowatt charging rate? And what are your thoughts on using 300 kilowatts versus 450 kilowatt chargers?
So I think the question is, how long does it take to charge a bus with one of these chargers? And I think it's between, depending on how charged the buses, but it's something on the streets between 5 and 7 minutes. So it's not a long charge, depending on where it is. It could just be during a layover that you already have there. From what I know of chargers, which is a lot less than some of the other members on this panel, and if you're using 300 kilowatt instead of 450, I think that means it takes, a third longer. So I guess the question would be, if you have the ability for longer layovers, presumably you can afford to have lower charge rates. If you have a need for quick turnover, a layover turnover when you get to that charging location, then you're going to need higher rates. So I think that's the answer to the question. For me, I would always want, if we could do it, if we knew at a particular location that we would never need more than 300, that's what I would install. Presumably, the lower the wattage, the cheaper they are. But if you're sometimes you got to be careful to sort of look into the future, because the routes that are charging at that location now may not be all that gets charged there in the future. So, size it to what you need, but pay attention to what it is down the road, because they're not inexpensive to put in. And I have no idea how easy it is to switch, if you could, from a 300 to 450. Maybe one of my colleagues on here could answer that, if that's a question people had.
Could I make a comment just on the bus side? The type of bus will have an impact on how much charge you can accept. So Brampton and TransLink were all using rapid charge buses that could accept 450 kilowatt charging, but a long range bus that has more capacity might only be able to accept 250, 300 kilowatts. So you can future proof based on, maybe your fleet is going to change, but at the same point, you don't necessarily want to oversize your charger if your bus isn't going to accept that today.
Yeah, can I bring in a quick comment here as well? So for the charging, so thinking of let's say a bus that has a 440 kilowatt hour, pretty much. When you're charging at 450 kilowatt charger, it takes a full hour almost to fully charge the bus. But we're not doing that. In those 5 to 7 minutes, we're topping it up. And that's where it brings this advantage when you have, let's say, 450 over 300. Not for the overnight charging, but more for those type of what we call opportunity charging. But in general, from a product perspective, that's why we're introducing the 360 kilowatt power, because right now you have 360 kilowatts in one power cabinet, versus previously we needed similar 3 power cabinets of similar size to bring in 450 kilowatts. So it's we're going in between. So 360 kilowatts, I think we find it as the sweet spot to target those type of opportunity charging.
Yeah, I just want to chime in that it's a holistic planning that we have to do. If we just look and we just say, okay, do I want the small tomatoes or the big tomatoes? Well, I don't know if you need small tomatoes or big tomatoes. Like, yeah, I know smaller ones are cheaper, whatever. But then maybe you need so many more plants, right? So you've got to look at the overall strategy and the trade-offs of how much cable, how much time, how many buses, how much space do you have? How much grid power do you have? How much battery? So, this is not, you have to be iterative. You have to use simulations. You have to look at all the scenarios. So it's a complex planning, problem where you have to understand all of the inputs and their impacts on the final situation. And 450, it's just sort of like all the options are good. We want all the options. We want to have high powered en route charging, because then if we're in a pinch, boom, we get that fast top up. That gives us resiliency. So it's a tool in the toolkit amongst, many others.
Also, if I may, like right now, the buses maybe will not observe the full 450, but like battery technologies is evolving pretty fast, and it's not like those chargers will be installed and then like replaced anytime soon, right? So I would not like advocate seriously for like scaling back on power of opportunity charging.
Thank you. I do have another question that could be answered, I think, by many of you as well. From Danielle Pike. So Danielle asked, with the cost or investment barriers to full network adoption being high, together with the technology developing fast, has any thought, give me 1 second, has any thought, apologies, being given to modular solutions that could be replaced or improved in situ as technology improves? So I think we could maybe look for maybe Erin, Vince, if you could give us your opinion on that as a member of the transit agency, and then the other panelists as well.
Well, I would say like right now, I said we're predominantly en route, but we are looking at ways for predominantly depot, with en route being a option in the future. But right now, again, we don't know where the buses and chargers are going on technology perspective. So what we're doing now is assuming that the life of the charger is going to match up with the life of the bus. So when we go to upgrade our next generation of bus, we would get the next generation of charger to align with that. But all of your cabling and your supporting substations and all those things are going to be the same. So it should just be a drop in some minor updates in the future. You're looking at pretty major costs initially, but once you have that architecture already in place, scalability and transitioning based on latest technology should be much simpler.
Yeah, I think my answer would echo a lot of what Erin's saying. For sure, though, our pilot is all opportunity chargers. Even the one in our depot is an opportunity charger. But we really would much rather have in depot charging overnight while buses are parked, and even during day while they're parked. And the principal reasons right now we're paying about 14 cents a kilowatt hour in depot, or doubling that on opportunity charging. So we'll look to do way more in depot charging because it's more cost effective for us to do that, and use the opportunity charging where you don't get enough mileage out of a bus and you need it. So, you used to buy old diesel buses. Nobody would buy a diesel bus that couldn't run 340 kilometers or 350 kilometers without a tank, without having to be refilled. It's no different if it's an electric bus. You want to get that kind of kilometerage out of it. And for us here in Brampton, many of our routes are the buses are out there for significantly longer than that. So those are big issues for us. And so as much in depot charging as we can do, we will do. On route charging, we'll do it where we need to. It wouldn't be our first choice. And again, we are looking at, hopefully those chargers have a reasonably similar life to the bus assets they're filling up.
Marie-Ève, if I can add in, this is where rate structure innovation is going to be critical. Because as you can see from what Vince just said, that's a problem, right? Why is he having to pay that amount of money? So we have to understand first there's an education, for example, in Ontario about whether one's going a Class B or a Class A customer. What does that mean? How can one play that business case? And in every jurisdiction where there's demand charges, how do you handle that? And then at the same time, doing a lobbying effort with your respective government to say, hey guys, if you want to do this, let's do it in a way where when you have surplus power, you give me an incentive that makes it super attractive for me to take it, and thus enables this social transition. And that's where we cannot have these discussions isolated. Otherwise, the costs will be super high. This is going to be super expensive if we don't optimize the grid as one entity. Right. So that's why we have to have the discussions also at the provincial level to make sure that we're thinking about the energy system, the whole system operation in each province, and making sure that it's an optimized way forward.
Yeah, and this is really an important point of view, because when we talk about hydrogen fueled buses, let's say fuel cells, we talk about infrastructure and the way to build the infrastructure. And we need to think about it exactly the same way for it. It's not that the fact that we have electricity, that we have the infrastructure ready for this. And this is why, for now, for the time being, until the infrastructure gets the upgrade it needs, we really need to manage with software and optimization of energy management and the energy side for all the different power needs, especially for during the peak hours. And that's why part of it as well, one of the tools is this variable type of tariff pricing to shift the demand towards the night versus the daytime, for example.
Right.
Thank you very much. I do have a question that is kind of simple, but not so easy to answer. So Jim Pegg asked, what life expectancy, do you expect? Do you have on the chargers and the pantographs? So maybe Teresa, Mohammed, but also the others. What were your the expectations that you have for the systems that you decided to go with, for instance? So Mohammed first.
Yeah, so basically for the ideal way is always to really make the most out of the charger, and with regular maintenance, predictive maintenance, do the upgrades necessary when they are due to really prolong the lifetime. But typically we're limited when it comes to the charger, we're limited to the power electronics lifetime. Everything else is easily replaceable, cost-effective, replaceable, or upgradable, but the power electronics is the main limiting factor. And we're talking typically the choice of power electronics we're having and the availability, we're talking anywhere between 10 to 15 years. So if the proper maintenance is done, you're talking more about 15 years by making sure that by maintenance, it's properly ventilated, they're not overheating, because usually heat is what causes the life loss of power electronics the most. So this is basically all comes in the maintenance operations.
So that's an excellent answer. I'm glad to hear that. But one thing I would ask myself, if I'm allowed to ask a question, is, we've seen where we have difficulty getting sourcing parts when they're beyond the warranty period. So if we have, say, an 8-year warranty, and we're hoping to get 15 years out of the charging infrastructure, are you suppliers going to be around to provide those components and those parts to us so that we can get them to the 15 years?
Yeah, can I comment on this one? So, and this is part of the life cycle that we have for the product. So for all the products that we're offering, we have an active phase, which is basically mainstream production, classic phase, which is basically, it's not mainstream production, but we still have all the spare parts available. And then the limited phase, which is basically where we still have parts available, but you need to kind of order it in advance and have it ready and available and stocked somewhere, basically. And this gets us into the 15-year range, let's say, for spare parts. And then it becomes obsolete. And that's basically when we need to look into either retrofitting and making use of, let's say, the power cabinet, the structure that's available, and retrofitting what's inside, or replacement.
I've been in the transit a long time. I can tell you we often keep our assets long past the obsolete point.
Yeah.
Yeah, Mohammed did a fabulous job of answering all of that, far better than I can. And so thank you, Mohammed, for that. But I would just say on the spare parts of it, I think it's a super valid point. And, we're bringing a new technology into the market, into this geography, right? And we want these spare parts like here. We don't want to get them from random where we don't really know where they are and how long is it going to take. And now there's a logistics problem. There's a ship that's not, whatever, right? So I think please, I would say dear customers, please specify and say to the market that I would like a strategy for local spare parts warehousing or whatever, right? And as the scale, at first it'll be expensive and, they will struggle, right? But then over time, as more and more transit agencies request and the technology comes to scale, we'll have more and more parts and it'll be faster and it'll be less expensive. So I think we just have to get this whole chain going so that we scale up the whole thing. So it's like we're just getting it from down the street and not from Timbuktu.
Right. Thank you.
Thank you. I do have a question that would be for Erin about Winnipeg and your project. So Jonathan Chai asked about mixed fleet, the possibility of mixed fleet. So did you consider fuel cell electric buses and bus electric buses being located in the same depots, or will you keep different technologies separate?
Right now, it's a plan. We have 2 garages that will be mixed and one that would be 100% battery electric, based on what we know today. So within that garage, the buses may be kept separate from each other, with different requirements for fueling versus charging. But strategically, fuel cell buses are part of our resiliency strategy. So 2 of our garages are very near to each other and one is far away. So if we had a power outage that affected one garage, we wanted, the ability to deploy enough buses from our other garages from, battery electric from there. But the fuel cell buses really can go anywhere in our service. So there's a lot more flexibility in terms of where you can deploy them. So distributing those buses across 2 garages was, more important to us than potentially the cost reductions that we'd have by a single garage.
Thank you. We also have a question asking, so do you need to provide air conditioning in electric buses charging garages? Is that necessary? So Roberto, do you want to say a few words on that?
Yeah, sure, no problem. Thank you, Maria. Yes, in general. So that's one of the questions that few people think of prior to their electrification plans. And one thing is a trial or a pilot project, and another thing is full fleet electrification. So you have to think like a big charger room with dozens of chargers generating heat all at the same time. And not only air conditioning, you have to think about the mechanical structure in there. There's a lot of added weight to your depots. So in general, there's plenty of other considerations to be made in terms of mechanical, architectural, and electrical as well, sizing correctly your electrical service in your depot. That is something that we can usually help transit agencies with as full rollout planning study, as we have conducted for London, and you guys had the opportunity to see Kelly spoke earlier on today. But in general, yes, and that is not your only preoccupation that you will need to have to electrify your whole fleet.
Vince, do you want to add something?
Yeah, I think that's absolutely the case. I mean, to some degree, it's are you replacing high-powered ventilation systems with air conditioning for what's there, but you absolutely need to look at the air conditioning. That's part of what we're looking at. There was a question from somebody about why we put our in-depot charger outdoors. Well, it had nothing to do with air conditioning. It's just a matter of that was the most convenient place to put one. But we're not looking to do, if we're going to retrofit or build new, we want all those indoors. And the air conditioning part of it is a big consideration. For what you've talked about. I mean, in other considerations, for example, we know there was a large fire in Stuttgart not so long ago that pretty much wiped out their fleet. So we're paying a lot of attention to what does that mean. So it isn't just air conditioning. There's all kinds of things you need to be taking into consideration when you bring electrical vehicles indoors and you're charging them. So it's just I think that's just one more thing on this long list of items that you want to look at. And it's a significant trade-off between infrastructure and operating costs. And if you don't like air conditioning in your facilities, do a lot more opportunity charging, but then you're going to pay a higher price, and you're going to have chargers all over your city. So these are all the kinds of considerations you have to take to do this. It's not that simple, but if you're using some other technology, you're going to have other considerations too. And us, like Erin, we believe it's not going to be all battery electric buses. We believe it's going to be a real mixture between battery electric and hydrogen fuel cell And part of it's for the reason I talked about is how far buses can go without a charge. And maybe those ones that can't go as far, you need where you have longer routes. Maybe that's where you're going to use your hydrogen buses. And they come with other constraints as well in terms of fuel availability and ventilation and things of that nature.
Thank you so much, Vince. We've actually run out of time. And so if any of you, well, thank you first of all to all our panelists and also all the audience for your great questions. And if you want to continue the discussion, actually, there is a networking session taking place at 5:15 Eastern time today. So for the virtual networking, you're invited to come and go speak to our different panelists. And I also invite you to go to our next session, which is our sponsor keynote with Jennifer McNeil from New Flyer, which is starting right now. So thank you very much again for your participation and have a great day.
Thank you.
Thanks, everybody.